All right, so here we are, first section of the semester, 7.1. Notice this class starts in chapter 7, looking at measurement. And we're starting off with US measurement. Make sure this is. All right, so we're going to start with a few measurements. Let me erase this. 12 inches is equal to 1 foot. 3 feet is equal to 1 yard. 36 inches equal to 1 yard. 5,280 feet is equal to 1 mile. Of course, these are not all of our measurements, just a few to start us off with. Don't forget, if you ever lose track or can't find any type of relationship, you can ask Google, Siri, Alexa, whoever. They all the same. It don't change. So if you can't find them in the book, you can always look them up. How many feet, in a yard, how many inches are in a foot, and so on. So now the way we're going to use these measurements is by these proportions over here to the right, or in this fashion, I should say. Either I'm going to use 12 inches over 1 foot or 1 foot over 12 inches. Same thing with the 3 feet to a yard. You're either going to put 3 feet over 1 yard or 1 yard over 3 feet. So what dictates how you use it is dependent upon what you're being presented. So I'll give you a chance to finish writing that. And of course, if I scroll up too quick and someone's still writing, feel free to unmute and say, could you hold on for a second, or could you scroll back down for a second? And it's not a big deal. All right. So the first one is 18 inches, and we want to convert it to feet. All right, let me erase some of this stuff so we can walk through it. All right. So we're starting off with 18 inches. And you can write 18 over 1 to set it up as a fraction. Now, the relationship that we're looking for is what gives us the relationship between inches and feet. And we just finished talking about that one, which is 12 inches equal to 1 foot. So as I mentioned, we're either going to use it this way or this way. So what will dictate that is how we're starting. We're starting with 18 inches. So if that's the case, I'm going to multiply it by a fraction that has inches in the bottom. I need my inches to be here and here in order for me to continue on. Same thing with anything else. If I have yards right here and I want to keep going, I need yards down here so that they can cancel out. And that's what's going to happen for us. So that means I will set this up as 12 inches on the bottom with your 1 foot on top. That allows for my inches to cancel. Inches over inches will cancel, just like if I had 5 over 5, those will cancel. Same type of thought process that you're doing with your cancellation of your fractions. And then from there, we'll multiply across. And notice that we are in feet, and that's what we need to be in, because that's what we're converting to. So that'll be 18 over 12 feet. Divide that out, and that'll be 1.5 feet. And Web Science should let you know how they want the answer. If they want it in fractional form, you could have, reduced by 6. 18 is 6 times 3. 12 is 6 times 2. The 6's would cancel, and that would leave you with 3 over 2 as a fraction. So Web Science will let you know how they want to answer. This one should be fine, but if they say something about a fraction, 3 over 2 would be that answer. All right. Questions on how we did that before we do another one? So once again, you'll start off with a relationship. In other words, we're going from inches to feet. Go see what conversion factor will help you out in that case, and then use it accordingly or use it properly based on which one you're starting in. All right, let's try it again. erase this stuff.
Do we have these slides in Blackboard?
Stop talking.
You said, you talking about what we're doing right now, the actual lecture?
Yeah, do you post those?
No, I will. I'll give you a YouTube link of the whole video of the lecture. hmm And so, and don't forget, I've actually already given you all of the videos from last semester as well. So, if anybody wanted to move ahead, I sent you an email of that, and it should be in your announcements in Blackboard. It should be entitled last semester's lectures. So all of these lectures, you already have like all of them, all of the class lectures. So yep. So yep, you'll get today's lecture before the end of the week, and like I said, you have the other ones archived as well. All right. So here we have 14 feet to a yard. So you go back to your conversion factors. You're trying to figure out where you have a relationship between the feet and yard. And of course, that'll be right here. 3 feet is in 1 yard. So now, if feet is right here, that means when I set up this next fraction, I need feet to be down here. So if I know there's 3 feet in 1 yard, that means 3 feet would be down here and the 1 yard would be up here. All right, any questions on that? Feet cancel, multiply across. That'll be 14 over 3. And we're in yards because that's the measurement that's left. That's what you needed as well. And if they want that in decimal, that would be 4.6. 6 would be repeating. All right. Any questions? All right. So the next one, 3.5 tons to pounds. So we didn't mention tons to pounds initially. I could have wrote that better. Let me write that better. There are 2,000 pounds in 1 ton. Also, I decided to convert that mixed number to an improper fraction. So you do that 3 times 2 plus the 1. So that's 7 over 2 tons. So let me erase. All right. So we have 7 over 2 tons. And we're going to use this relationship of 2,000 pounds equal to 1 ton. So we got 1 ton down bottom, 2,000 pounds up top. Tons cancel. Multiply across. 14,000 pounds over 2. And 14,000 divided by 2 is 7,000. All right. Questions? Any questions? So hold on. Make sure you hold on to that process because we'll come back to it. That process can work as long as you have your conversion factors. As long as you have a conversion factor, you can use this process. whether you're dealing with US or any other type of, or if you're converting from US to metric, which is what we'll come back to. All you need is that conversion factor, and then from there, set up your fraction and use the same thought process of canceling out, and that'll let you know which one should go on the top and which one should go on the bottom. All right. The next one is the metric system, which is the system that the whole world uses. You know, the other one's called the US system of measurement because only the US really use it. This metric system is what everybody uses. When you have your prefixes, and some of them you should be used to dealing with because, you know, you gigabytes, megabytes. So you have very, very large prefixes that extend past kilo, and then you have very, very small ones that extend past milli, like nano and pico. All right. So those are your abbreviations for those prefixes and their value. So kilo is K, hecto is H, deca is DA. Now your base, we're going to talk about that more so in a second. You're talking about grams, meters, and liters. But then deci for D, center, C, and milli, M. All right. Everybody good? Don't want to leave the chart if anybody's still copying. All right. So your bases, these are the measurements that you will put the prefixes after. We have grams for G, that's going to measure your weight, meters for M, for measure length, and then liters, L, measures volume. All right. So here just showing you how no matter what base you can have kilograms, kilometers, or kiloliters, centigrams, centimeters, centiliters. You can put either one of those prefixes in front of either one of those bases. All right, so the order is going to matter. If I go back here, notice you have your value of 1,110, 1/110th, excuse me, 1/100th, 1/1000. So the order matters as far as their value is concerned. So you need to keep that order. So the way you can remember the order is remember that King Henry died by drinking chocolate milk. K for kilo, H for hecto, D for deca, then B is your base. And so depending what base you're dealing with, whether it's grams, meters, or liters, just want to write that cleaner, that base would be that. Then D for deca, C for center, M for milli. So King Henry died by drinking chocolate milk. All right, let me just right, so let's look at the first one. We want to convert 0.38 meters to millimeters. All right. First thing we want to do is recognize what measurement we're in and where we want to go. So we want to go from meters to millimeters. Here we have our measurements, and they're in order. King Henry died by drinking chocolate milk. Remember, B is your base, and that is M. So we're going from M to mm, meters to millimeters. So we go 1, 2, 3. We went 3 to the right. So we go to our value, go to the decimal, and go 1, 2, 3 to the right. Now, if there's nothing there, then you add a 0 as a placeholder. And that will mean 380 millimeters. So when you're dealing with the metric system, all you're doing is moving the decimal to the right or to the left accordingly. All right. And how many spaces you go to the right or how many spaces you go to the left will be dependent upon, what measure you start off in, what measure you're trying to get to. All right, questions. All right, let's do it again. This time we're going from centimeters to hectometers. Trying to erase this stuff and walk through it versus just having it up. All right, we have 12.9 centimeters and we want to go to hectometers. So once again, I have our measurements listed in order. This time we're starting in centimeters and going 1, 2, 3, 4 to the left. So I take that 12.9 and go 1, 2, 3, 4 to the left, using 2 zeros as placeholders. So that's 0.00129 hectometers.
Wait, why is the decimal in between the 2 zeros?
It's not in between these 2 zeros. I thought I heard somebody else. It's not in between those 2 zeros. That's just a 0 that's sitting on the left. You could have wrote it like that and it still would have been fine. Notice we still have our 2 zeros right here. So those 2 zeros are right here. All right. Question before we go to another one? Everybody good? All right. Next one, we're looking at 4.23 decagrams to centigrams. So instead of having meters, we have grams. So notice our base is G instead of M. And we have all of our prefixes in front of the G. All right. So you start with decagrams and you go 1, 2, 3 to the right. 1, 2, 3 to the right. So add a 0 here. So all right, so that's 4230 centigrams. right, then we got at least one more. Questions though, anybody? Everybody good? Everybody straight? Once again, we look at the metric system, all you're doing is moving the decimal however many places to the right or left accordingly. All right, so this time we have liters as our base. 1,579.64 milliliters, and we want to go to hectoliters. So starting in milliliters, and we're going 1, 2, 3, 4, 5 to the left. So take that original number, do that. 1, 2, 3, 4, and 5. Use a 0 as a placeholder. .0157964 hectoliters. Questions before we go to the next one? I should entitle that US to metric. So now, if you're converting metric to metric, you're just using the metric system, then you can do what we just finished doing. But if we're trying to convert US to metric, then we have to go back to what we were doing initially when we had a conversion factor. Notice we were dealing with miles. We want to take 55 miles to kilometers. So you're talking about this being US, this being metric. So if you want to convert between US and metric, then you're going to have to use a conversion factor. Once again, they're all set up or lined up in the book. If you can't find the book, always Google it. You can, like I said, any device, your phone will be able to tell you how many kilometers are in a mile or how many miles are in a kilometer. Either way. So let me erase this so we can walk through it. I'll get that back. So we have 55 miles, and we have this conversion factor of 1.61 kilometers equal to 1 mile. So I need miles down bottom. So I do 1.61 kilometers with the mile on bottom so that the mile can cancel. Mile over mile will cancel out for us. So now you just multiply across. .55 times 1.61 should give us 88.55. And 88.55 over 1 is that, will be how many kilometers that we have. All right. And like I said, that's the same process that we did initially. You have a conversion factor, and you set it up according to your fraction. All right, questions. For some of us, some questions may not show up until we actually start doing the work, start trying out your homework. That's all 7-1 is about. So make sure you do try the stuff. See if you have any questions. You can always email me. If not, then, you can hold it for next class, whichever way. But you do want to make sure you try the stuff out as soon as possible to see if you have any issues with converting between your measurements. All right. So once again, there are only two ways that we talked about converting to your measurements is by using this fraction and using your conversion factors, or using the metric system when you're moving your decimal to the right and left. All right. So let's start 7-2. Not saying we're gonna finish it, but do want to go ahead and get started in it so you guys can have some work to do. We got 7.2, which is basic concepts in Euclidean geometry. All right, let me erase some of this. Erase that without delete. There we go. Good. So first exercise that they give in this section says X and Y, or X, Y, and Z, excuse me, are all on line L. I guess I can do it like that. All on line L. Says given that XY is equal to 9 meters and YZ is twice XY, find XZ. So right there in the black is a little diagram of what they're saying. You have line L, X, Y, and Z are on that line. XY is equal to 9. So XY is equal to 9. And then YZ is twice XY. Find XZ. All right, so you want to find from here to here. How much would that be? So if you just had to set it up as an equation, notice I have xy plus yz is equal to xz. You have this, oh, get my pen back. You have this piece plus this piece, gives you the whole xz. And they told us the relationship that yz holds is twice xy. We know xy is equal to 9. So xy is equal to 9. Then I also put xy equal to 9 right here. So that's 2 times 9. 2 times 9 is 18. 9 plus 18 is 27. So even if you didn't write it all out like that, but that's how you would, process the situation. You know that xy is equal to 9, and then yz is equal to 2 times 9 because it was twice xy. And then when you add those together, that'll give you that 27. So once again, even if you don't set it up completely like this, that's still the thought process behind it. All right. Any questions on that first one? All right. All right. Sounds good. Let's scroll up. Next one, A, B, C are all on line L. I don't know why I didn't label these L. But given BC and AB, I don't know what I mean. BC, Kelt and AB. What is that, Kelt? What did I write? Oh, 16. I was like, why did I write that so close together? Sorry about that. That should be 16 feet. So BC is equal to 16 feet, and AB is 1/4 of BC. Find AC. So very similar to what we did last time, just that this time we have 1/4 involved. So I just want to make sure we're okay with the fraction work. So it's telling us that I'll go blue, green again. BC is 16, and then AB is 1/4 of that. So our setup, you have AB plus BC is going to be equal to AC. And we know that AB is 1/4 of BC. We plug in the 16 for BC. 1/4 of 16 is the same thing as looking at 1/4 times 16 over 1. You multiply across 16 divided by 4, which is equal to 4. So that's where we got that 4 from. And then 4 plus 16 is 20 for AC. All right. Next, we're looking at parallel lines, lines that never touch or cross. So lines that never touch or cross each other because they have that same incline. Perpendicular lines, lines that create a 90-degree angle at their intersection. All right, so it's a diagram of that. You can never assume that you have 90 degrees. You always have to make sure that you see some indication. Oh no, let's get back to my drawing. There we go. You have to make sure that there's some indication that you have the 90-degree angle. So most of the time you'll see that square, the red square. If not, then there had to be something in the direction that say you have perpendicular lines, but you can never assume that you have 90 degrees. To the naked eye, 89 degrees looks just like 91 degrees. So never assume that you have 90 degrees. Has to be some clue that lets you know that you have 90 degrees. All right. Angles are two rays with the same endpoint. And that endpoint is called your vertex. Types of angles. Your acute angle would be between 0 and 90 degrees. We mentioned a right angle. That's 90 degrees. Once again, don't forget you have to see that square in there. obtuse angle would be between 90 and 180. Then we have a straight angle, which is 180 degrees, basically a straight line. Full rotation or revolution is 360 degrees. All right. Any questions? Complementary angles are two angles that add up to give us 90 degrees. 50 and 40 are complementary. 1 and 89 would be complementary. Supplementary angles, two angles that add up to give us 180 degrees. So 150 and 30 would be supplementary. 178 and 2 would also be supplementary angles.
Can you slide up just a little bit so that I could see the numbers for the complementary angles, please? Thank you. I have them.
Okay.
That's too many questions.
That's too many. What? What happened?
Too many questions in class.
Y'all are funny. So, did you say you were good with the complimentary?
Yes, thank you.
All right, yeah, no problem. And then there go supplementary. Make sure everybody's good on that. All right, so let's look at an example. The next example that he gives says, given that here, this symbolism right here, and with that looks like an angle, then ABC, that just means the measure of. So given that the measure of angle ABC is 84 degrees, find the measure of angle X. And then it gave us that diagram right there. So they give us this whole diagram right here. Notice ABC is this whole thing right here. And they give us 47 degrees. It's a part of ABC, and then the other part is X. So this is our missing part. They gave us 47 degrees of it. So if you want to know, and just like before, you don't necessarily have to set it up as an equation. You already know, if you already know what to do, then that's fine. But this is just the process of setting up an equation. You know that this X plus this 47 is going to equal to ABC. So you subtract 47 from that 84 degrees, and 37 is what X is equal to. All right. So once again, the equation isn't mandatory to use, but That's just the process mathematically what you will go through. As long as you see that you should be subtracting 47 from that 84 to get your 37, then you're in a good place.
What's the number in red under 84 degrees?
I swear y'all asking me.
But leave them people alone. Let them ask their questions. Everybody can ask. Y'all can ask questions, whatever questions y'all want to ask them.
Yeah, what's
Just
that number?
right here, 47.
Okay.
Y'all are too funny. Let's see. Yeah, we got plenty of time.
Professor,
Yep.
that's not funny. This is a classroom. This should be an open environment for us to ask unlimited questions.
Oh, yes. Yes, you're absolutely correct. It was something that I would address. I was going to address at some point. But you're absolutely correct. But I don't believe that she meant any harm. I think she was joking, if I'm not mistaken. I think she was just playing. I didn't hear any malicious intent in her voice, so that's why I didn't take it maliciously. You know what I mean? So, but I was going to say that might want to chill on that because some people may not get the joke. But really, if I felt like she was being malicious with it, then I would have did that initially. But I really didn't think she was being mean with it at all. So, yep, yep. But
I'm
hmm. Somebody say something? Okay. All right. So let's look at vertical angles. So vertical angles will be formed by the intersecting of lines. It's the non-adjacent angles. Write that to you better. Adjacent angles are the vertical angles and are equal. So what we mean by that is this diagram right here. I know I didn't get so the only title is vertical angles. I think I moved up a little too quick, but vertical angles is the title. Those are the type of angles we're talking about. And when you look at what angles are considered vertical, 1 and 3 are vertical angles. So notice that they're opposite of each other, and they are the angles that are equal to each other. And then 2 and 4 will be vertical angles, or vertical angles towards each other. And they will be equal as well. All right. Make sure we're good before I scroll up to the example. And I didn't mention that right here. I just said VA for vertical angles, just in case, So it's like where VA come from. So just doing vertical angles for short. VA for short, I should say. All right, so this next example, find the measures of A, C, and D. And let me erase some of this stuff so we can walk through it. And oh, I didn't need to erase that one. Somebody said something in the chat. Let me see what's going on. Oh, can you hear me now? Because I wasn't talking then. I was just erasing stuff. Can you hear me? Can you hear me? Yes, no, maybe so. All right. So it says find the measures of A, C, and D. They give us B and want to find A, C, and D. This is the diagram. So now the easiest one to find, you recognize that we have vertical angles here. So these two are going to be equal to each other. So we know off the top that D is going to be 115. And that is a vertical angle with B. All right. So now we can find A or C. It doesn't matter which one we decide to go first, find first. If I want to find A, I see that I have a straight line that's created with A and B. So to find A, I can do 180 minus 115, which would be 65 degrees. So that is a straight angle with B. So anytime your lines or your angles form a straight line, they're supposed to add up to give you 180. So we knew what B was, which was 115. Subtract that from 180. That will give us what A is. And then we have that vertical relationship, vertical angle relationship again, but this time it would be between A and C. So that means C is 65 degrees. And that is because it's a vertical angle with A. Or if you wanted to subtract that from, subtract 115 from 180 again, you still got a 65 because it creates a straight line with B as well on the other side of that. So a lot of times there's multiple ways to find the angles. It just depends on which one you see first. But if you do it correctly, you'll still get the same answers. All right. Questions? Any questions? All right, let's look at the next one. So we have L1 and L2 are parallel lines. And T is a transversal. Transversal is just a line that goes through, that runs through the two parallel lines. So we're going to talk about the relationship between these angles that are being formed. First one is alternate interior angles. Let me wait for you. Make sure you guys copy that first before we go to alternate interior angles. Give you a second. All right. So alternate interior angles, first thing we want to know is that they are equal. And these would be what they are, alternate interior. So you're talking about, when you say alternate, you're talking about opposite sides or alternating sides of your transversal. And interior, you're talking about the inside. All right, so you're looking at D and X will be alternate interior angles, and then W and C, alternate interior angles. They're on the inside of your parallel lines. So once again, it's in the wording, alternate, which means alternate side of your transversal, and then interior, which is the inside of your parallel lines. The outside is where A, B, and ZY are located. All right, questions on those relationships? All right, next one's alternate exterior angles. So they're going to be equal. So once again, alternate, talking about opposite sides of your transversal or alternate sides of your transversal. And now we're looking at the outside angles, AB and ZY. So AY will be equal to each other and BZ will be equal. Once again, alternate sides of the transversal and exterior on the outside of your parallel lines. In the last relationship, corresponding angles, they are equal. So let's go back to the diagram. What we mean by corresponding angles is that this cluster corresponds with this cluster. So that means A and W, B and X, D and Z, C and Y. So corresponding angles, the whole cluster correspond to the other cluster. So as you see, you have multiple relationships that you can use that will help you find out what angles are. So all they have to do is give you one, and you will be able to find out all 8, or the other 7, I should say.
What was the second kind of angles you talked about?
Alternate exterior.
Thank you.
Not a problem. I gotta write this stuff a little better. I must have been tired when I wrote this stuff. Gracious. Yeah, about the same. It's all right. All right. Any questions before we use these relationships? Let me see how much more is after this. Got triangle. Okay. Yeah, we almost finished. Okay. So let me erase some of this stuff. Let me do that. That's H, G. All right. So in the diagram, we have L1 is parallel. And that's what that means when you have those two lines like that in between your letters. So this L1 is parallel to L2. And I didn't write L1 and L2 right here. L1 is parallel to L2. And the measure of angle F is 58 degrees. Find the missing angles. All right. Once again, I'm going to erase some of this stuff. Well, erase all of it. And we'll walk through it. All right, so the only one we have at this moment is F. That's given. So it's up to you where you want to start first. It does not matter as long as you use the proper relationships. You'll still be good to go. So if we look at H, we can see that they form vertical angles. So that means H is going to be 58. It's a vertical angle with F. All right. Next, and like I said, it doesn't matter where you go next. If you want to go and try to find something up in this upper cluster, you still have that, that ability. I mean, you can do whatever you want to do as long as you're using the same, the proper relationships. I'm going to look at G. I see that G, F and G form a straight line. So I would do 180 minus 58, which is 122. And I did that because that is a straight angle, a straight line. Yeah, straight angle with F. All right. Then looking at E. E we know is 122 because that's a vertical angle with G. So before we go any further, make sure we're okay with those four. All right, so we have these other four up top. And one way we could look at it is that we have this cluster of angles that's supposed to mirror the other cluster. So if I look at A, stay purple. In fact, A is going to be 58 degrees. It corresponds, or corresponding angle. I just say CA. Corresponding angle with F. B is 122. That's a corresponding angle with G. C is 58 degrees. I can use corresponding angle, or I can say it's a vertical angle with A. And D is 122. Once again, I could say corresponding angle, or I could say vertical angle with B. So once again, there's multiple ways you could find the value of these angles, but notice there was only two answers, 58 and 122. So try not to, get overwhelmed when you look at something like this. We're just alternating between the numbers 58 and 122. And that was it. Any questions? Any questions? All right, we have one more relationship to talk about. And that's the angles of a triangle. So the angles of a triangle add up to give us 180 degrees. So if I have an angle that's A plus B plus, that has A, B, and C in it, if I add up those angles, once again, they should add up to 180 degrees. All right, I believe this is the last example of the day. Yep. So in the diagram, angle C is equal to 40 degrees, angle E is equal to 60 degrees. Find the angle of D. So let me erase some of this stuff because some of this stuff wasn't here. Yeah, don't want to erase that one. There we go. So they gave us the diagram in this way. And it says in the diagram, angle C is 40 degrees. Angle E is 60 degrees. And they want us to find angle D, which is on the outside of our triangle. See, we have a triangle right here. So let's look at what's given. Let me erase some stuff. All right, so I like using the blue for my given. All right, so we have A, B, C, D, E. And we know that E and C were given, but we need all of A, B, and C, D, C, E in order to find D. So we recognize first that we have a triangle, like I mentioned, but we don't have all the angles of the triangle, and we need this B in order to be able to find out what D is. So we can see that angle A is going to be 60 degrees, and that's because it is a vertical angle with E. So now that we have angle A, we can find angle B. So we would take 60 and 40 and subtract them from 180. And that's because angles of a triangle, they add up to give you 180 degrees. So we had two of them, and we subtract those two from 180, and that'll give us the third one. All right, so that's 80. Any problems? Make sure we're all right before we find our final answer. All right, so now to figure out D, which is the answer that we needed, it would do 180 minus 80, which will give us 100 degrees. And that's because it forms a straight angle with angle B. All right. Questions on that? Very good. Everybody straight. And yeah, like I said, that's it for 7-1 and 7-2. I don't know what to say. No, what this one is going to look like. Well, it's going to be, someone asked in the chat, is the homework going to look like this? It's going to be some variation of it, using these concepts, using these relationships. And yeah, so you have to use the concepts and relationships that have been introduced today in order to find, whatever angles are missing or what conversions, whatever measurements they want to convert. And, go from there. And, any question that you have, you can always feel free to, ask it. We'll look at, getting you through it and everything like that. But yeah, it'll be some form of this. All right. Any other questions before we close out today? Still not able to log into WebAssign? When was the last time you tried? Today? Okay. Now, did you email me about that? Because I'm trying to see, because I had a few people that emailed me. Okay. Either, and I emailed you. Okay, because the weird thing is I can see your names. I'll email the WebAssign representative and see what they can do about it. As a matter of fact, if you're having issues with WebAssign, email me again, and all I want you to do is in the title just write WebAssign login issues, so I can just forward that to the WebAssign rep. So all you have to do is type in WebAssign login issues. Where your assignments are posted, there's no due dates on anything right now, so you don't have to worry about that. And I am considering, the issues that we're having to log in, so you'll be fine. Yeah. Oh, you can start doing them now. We went through two lectures, so that's two sections that you guys are equipped to begin starting. So yeah, start them as soon as possible, so that when a due date is put out there, you're not pushing towards the due date and crunch time and all the stuff like that, because you already got it done. There's nothing else to do, right? So yeah, do them as soon as possible. Get on in there. And like I said, we're trying to figure out this login issue. Like I said, also make sure if you're having login issues, you shoot me an email that's saying, I'll probably maybe even send another message out saying, just WebAssign login issues. Make that the title. And then in there just saying having trouble logging in or can't log into WebAssign, as far as in the body of the email. But because everybody's not having that issue, I do have some people in there that's doing work. So for some reason, individual accounts are having issues. So I need to figure out what's going on, because I can see your names. And so I tried repopulating the roster, and evidently that didn't work. So that means we need to get the rep in, or the tech support to get in here and do some things. Anything else? Anything else? Everybody good? Sure. All right. So it's been a great class. We'll see you guys on Thursday, and have a good one. Everybody take care.
Thank you.
Thank you.
You too.
All right. Take care. Thanks. Y'all have a good one.
You too.
Have a good one.
Thanks. You the same. All right. Thanks. I'll take it. Check out the email.